Hey guys, this is a square. Let's call it A, with side lengths x here and here. So its area A sub A equals to x times x equals to x squared. Now let's say this square starts growing. This is where calculus gets beautiful. Let's say the side grows just a tiny bit, from x to x plus a small amount, delta x here and delta x here. So we have x plus delta x, and here x plus, hey, please subscribe me, delta x. Let's call the bigger square b. So a sub b equals to a sub a plus new area. Look closely at the new area we added here. It splits into three pieces, a thin strip on top. Let's call it 1. Then area of 1 equals to x, that is the width, and the height is delta x times delta x. And a thin strip on the side, same size. Let's call it 2. Then a sub 2 equals to x times delta x. And the tiny square in the corner, delta x by delta x. Let's call it 3. And we have a sub 3 equals to delta x times delta x, that is equal to delta x squared. Now let's add up these three added regions and call it a sub 1, 2, 3 equals to a sub 1 plus a sub 2 plus a sub 3. The question is, how much did the area grow compared to how much the side grew? Actually, the question asks for a sub 1, 2, 3 over delta x equals to, okay, that ratio is the derivative. A sub 1, 2, 3 equals to, hey, please subscribe me, delta x plus x times delta x plus delta x squared. Delta x squared. Now let's shrink delta x smaller and smaller, right down towards 0. And here's the thing, a sub 3 races towards 0 way faster than a1 or a2. So we can write delta x squared almost equals to 0, and we have 2 times x times delta x for a 1, 2, 3. Now let's go back to the question. We have a sub 1, 2, 3 equals to 2 times x times delta x, 2 times x times delta x over delta x. Cancels out delta x from top and bottom, and we're left with 2 times x. That's it. That's the derivative of x squared. We just saw and calculated the idea of a derivative without memorizing a thing. Next time someone tells you a derivative is just a formula, show them this square.